Good morning, all of you. For now, in this class, we will start a new topic. Okay, we will discuss about a new topic. So let's start that. The topic is moment distribution method. So we will start from that moment distribution method. Have you earlier got this in your earlier semester moment distribution in your previous semester? Okay, am I audible to you? Are you all listening? Okay. In the earlier semester, did you got this moment distribution method? Say yes or no. Okay, fine. So you have a you have little bit idea about this moment distribution method as you have earlier already got. But still, we will go through once. It will be revision of your earlier semester. So there are some terms in this moment distribution method. I think all of you heard about these terms: distribution factor, carryover moments, all these things you need to do. So there are some basic introduction about this moment distribution method. So moment distribution is an iterative method of solving an indeterminate structure. Moment distribution method was first introduced by Hardy Cross in 1932. Moment distribution is suitable for analysis of all types of indeterminate beams and rigid frames. So we can use this for frames also when we are analyzing a building. So in your final semester, when you did building project, when you need to analyze the beams and column, all these things, joints, all the frame, then you need to use this moment distribution method. Also, you can use another method, but this is one of this method. By using that, you can analyze any type of beams and frames. Okay. It is also called a relaxation method, and it consists of successive approximation using a series of cycles is converging towards final result. It is comparably easier than slope deflection method. This is another type of method. Slope deflection method, Carnage method, there are some method also. So it is comparably easier than slope deflection method. It involves solving number of simultaneous equations with several unknowns, but in this method does not involve any simultaneous equation. It is very easily remembered and extremely useful for checking computer output of highly indeterminate structures. It is widely used in the analysis of all types of indeterminate beams and rigid frames. The moment displacement method was very popular among engineers. It is very simple and is being used even today for preliminary analysis of small structure. So, what are the primary concepts used in this method are fixed end methods, relative or beam stiffness or stiffness factor, distribution factor, carryover moment or carryover factor. Okay, these are the terms we are going to use when we solve or when we use this moment distribution method. So, there are some basic concepts. In moment distribution method, counterclockwise beam and moments are taken as positive. The counterclockwise beam and moment produce clockwise movement on the joint. These are the sign we are going to use. Anti-clockwise is positive and clockwise is negative. Okay. So there are some assumption in moment distribution method. There are some assumption. You need to remember this. All the members of the structure are assumed to be fixed, and fixed end moments due to external loads are obtained. So whatever the structure, whatever the support is there, we need to assume it as a fixed. Okay, and by assuming the fixed, we need to find out the fixed end moments. Okay, we need to assume that the structure is fixed, and we need to find out the fixed end moment. All the hinge joints are released by applying an equal and opposite moment. The joints are allowed to deflect one after the other by releasing them successively. The unbalanced moment at the joint is shared by the members connected at the joint when it is released. You'll able to understand when we solve a numerical, it is very easy how it is balanced, how the distribution factor is used, how the carryover moment is going from each joint to another joint, each member to another member. We'll come to know when we will solve a numerical. So, the unbalanced moment at a joint is distributed into the two spans with their distribution factor. So, the unbalanced moment, whichever is left, that will be also distributed among all the members equally. Hardy-Cross method makes use of the ability of various structural members at a joint to sustain moments in proportional to their relative stiffness. Okay, so there are some friction moment. How we need to find out? All members of a given frame are initially assumed fixed at both ends. The loads acting on these fixed beams produce friction moments at the ends. Friction moments are the moments exerted by the support on the beams, and these non-axial moments keep the rotation at the ends of each member's zero. Okay, these are some configuration. If there is a point load, how we need to find out? What is the formula for finding out the friction moment? MA and MD. This is the set given. When there is a UDL is provided, how we need to find? They see there are some condition. Point load, this point load is given at the center of the beam, L by 2, L by 2 distance. So there is a different formula. Okay. Similarly, this is also a point load, but it is given at the different distance A and B. So for that, there is another formula to find out the friction moment. Okay. So there are some condition is given here in this chart. So as per the condition, we need to find out the friction moment. Okay. These are all some formulas, how it look like, how are the drawings and all these things, and the deflection. So this is one of our more important term, this relative or beam stiffness or stiffness factor. When a structural member of uniform section is subjected to a moment at one end, then the moment required so as to rotate the end to produce unit slope is called the stiffness of the member. Okay. It means if a moment is applied, say just for example, in this joint, if a moment is applied, so to counteract this moment, a equal amount of moment is applied in this side. So this is called nothing but this, and the slope which is produced, this is called the stiffness of that member. Okay, stiffness is the member of force required to produce the unit deflection. It is also the moment required to produce unit rotation at a specified joint in a beam or a structure. It can be extended to denote the torque needed to produce unit twist. It is the moment required to rotate the end while acting on it through a unit rotation. So there are some formula as per the condition. If the beam is hinged or simply supported at both ends, then this stiffness factor is given by K is equal to 3E by EI by L. And when the beam is hinged or simply supported at one end and fixed at other end, then it is given by 4EI by L. So for continuous beam and rigid frame, stiffness of all intermediate beams is given by K equal 4EI by L. If each support is fixed, it is given by 4EI by L. If each support is hinge or roller, it is given as 3EI by L. And where E is, you already know, Young's modulus, I is moment of inertia, and L is nothing but the beam span length. It is the span of the length. Okay. After this, one more important term, it is distribution factor. What is this distribution factor? When several members meet at a joint and a moment is applied at the joint to produce a rotation without translation of the members, the moment is distributed among all the members meeting at the joint proportionate to this stiffness. Means say if there is a joint, if there is a join and it's connected to different members, that through the join the all the movement is distributed among all the members, and it is distributed according to some factor that is called distribution factor. So distribution factor is relative stiffness divided by sum of the relative stiffness at that join. If there is three members, say, so this is distribution factor. How we will need to find out? K1 by K1 plus K2 K3, then K2 by K1 K1, and similarly K3 by K1 plus K2 plus K3. Okay, it will be clear when we solve a numerical. So don't worry, carryover movement. Next is carryover movement. So what is carryover movement? Carryover movement, it is defined as the moment induced at the fixed end of the beam by the action of a moment applied at the other end, which is hinged. Carryover moment is the same nature of the applied moment. It is given by CO, the moment applied at the hinge, B carry over to the fixed end A. So the moment equal or half of the amount of applied moment and the same proportional sense. So carryover moment is here, it is 0.5. So these are some tabular format. How we need to find out? See, this is a beam. That's example for the this beam. How we need to find out the distribution factor. So as you can see here, AB, which A, there is one single member is joined AB. So joint A, member AB, relative stiffness, it is 4EI by L, as it is. So sum of relative stiffness, there is one member. So directly you can put this. So divided by relative stiffness by the sum of the relative stiffness, you can easily find out the distribution factor as 1. And always remember, when there is a beam, if there is connected members is 2, 3, how many members are there, it doesn't matter, but the distribution factor, it always comes to be 1, and summation of that comes to be 1. See here in this point B, there is two member connected, BA, as you can see here, BA and BC. Okay, BA and BC. So this C, BA and BC, it is connected. So all the stiffness, relative stiffness we have written here. So by summation, at the last you see this 3 by 7 by 4 by 7. If you sum up these two, you will get 1. Okay. So let's remember how many members are connected. It doesn't matter, but the distribution factor of all these members is always come to be 1. Similarly, in this here also see in the joint C, it's 4 by 8 by 4 by 8. If you sum up this 4 by 8 and 4 by 8, you will also get 1. Okay. And this is another type of beam. Okay. This is also one example. I will share this with you. Okay, please go through these things. You always will come to know. I will not go to the numerical. Let's just do it. In the PDF which I have already given to you, here also it is written these things. So please go through this numerical. It will explain here how the carryover moment and all these things which I have already discussed with you. The stiffness, the distribution factor. See, this is all the diagram and all these things it is given. How it is need to find out. See, this is for expression for distribution factor. This is a derivation. How we need to find out distribution factor. So we are considering. Let us consider the rigid jointed plan frame as shown in the figure, in which there are four members. As you can see, there are four members: OA, OB, OC, and OT, meeting at the joint O. Let M be the moment applied at joint O. Since O is the rigid, all the members rotate by the same angle. Okay. So we are considering that same angle is theta. So let M1, M2, M3, M4 be the moments shared by the members OA, OB, OC, OD respectively. Then this 4 M1, M2, M3, this summation will gives us the total moment. I'm going little bit faster. It's very easy, just the theory things. Just or if you With these things you can easily understand. So let K1, K2, K3 and K4 be stiffness, and L1, L2, L3 and L4 be the lengths of the member of these members OAOB, OC and OT. That's with this. So our theta will be given by M1 by K1, M2 by K2, M3 by K3 and M4 by for every members. Okay. If we sum up this also, we'll come to finally get a value of this. Thus, a moment which is applied to the joint is shared by members meeting at the joint in portion of their stiffness. So, distribution factor is given by Mi by M. So, it's also given by K by all these things which I have already discussed. Just go through these ones, okay? So, in the next class, we will solve a numerical. Then it will be easier for you to understand how the all these things is applied to a beam. We'll discuss this numerical in the next class. So how the effect of all these loads and all these things come to the beam when we find out. So for before that, all of you please go through the theory part once. We'll discuss the numerical in the next class. Okay, we'll not start the numerical today because it is a longer numerical. It will take time. Is there anyone have any doubt? You can ask me or please give your attendance in the chat box also. Okay, thank you all.
Thank you, sir.
Is there anyone have any doubt? You can ask me. Okay, I am there. Please don't leave. Let me mark your attendance also. And please go through these things, okay, before coming to the next class. Please go through the theory once. It will be repetition for you also, as you have already earlier got the moment distribution method, but it is then okay. Please go through the theory parts. In the next class we will start the numerical. When you solve a numerical, all these terms will be used. So before that, all of you please go through the theory part once, okay. Thank you once again. Please give your attendance in the chat box. Thank you all. Is there anyone left to give you attendance? Shilpi, which is your correct numerity, 124 or 123? Okay, everyone. Thank you for today. We will continue in the next class. Okay. Thank you all.